Hello guys, good evening. You are welcome to my YouTube channel, the Explicit Tutorials. And of course, as you all know, my name is Tutor Joseph. Do not call me Screwdriver or Spanner or pass my neighbor or Dagger Generator. No, I'm just what? Joseph by name. And in today's video, I'll be taking on Chem 113, a subtopic called what? Assessment of purity. Yeah, I just came back from Canada. Yeah, I came back from Canada not quite long. Is it your Canada? Why are you not coughing? Well, I don't. Why are you coughing? If I had told you I just came back from Ugbogyobo, you would have believed me. Or maybe I just came back from Atopava, you would have believed me. Because I said Canada, you are coughing. Why are you not coughing? Please, my private airplane just touched down not quite long and it's legible from from here. Is it your airplane? It's your Canada. I'm leaving Nigeria for all of you. Do you think I'm not a Nigerian, I'm a Ghanaian, okay? So it's not your Canada. Leave it for me. It is my Canada. Now, assessment of purity. We are going to be using this means to actually know how pure a substance is. Now, we have different assessment to testing for the purity of what? A substance. Now, we have one, the visual inspection. Visual inspection. This visual inspection means looking at the compound. Just looking at it, you can tell the color, the size, and the shape of all the compound. This one is quite easy. And number two is the olfactory attributes. Olfactory attributes. Please and please let me see this. All of the assessment of purity, the one that is not advisable you do is this what? Olfactory attribute. There are some gases you will inhale, your brain will knock. It will knock forever and ever. A good example is what? TNT, a trinitro-toluene. It's a very poisonous gas. If you should inhale this gas, your brain will knock. You go meta. So please, olfactory attribute is just like sniffing what? A particular what? Compound. Please, it is not advisable you execute this type of what? Assessment. Please. Number three is what? Boiling point. Boiling point. Boiling point. So please take note of this. Pure substances, they have sharp and definite boiling point. They have sharp and definite boiling point. All right, their boiling points is definite and it is what? Sharp. And they boil over a narrow temperature that is about 1 degree what? Celsius. That is about 1 degree what? Celsius. Very narrow. Please, let me tell you. Now, impurities. The impact of impurities on the boiling point of liquid is to, okay, elevate it. Impurities in the boiling point of a liquid substance causes what? An elevation to the what? Boiling point. It increases the boiling point of what? Liquid. Please, the impact of impurities is to elevate the boiling point of what? Liquid. Elevate or what? Increase. Okay. And number four is what? Melting point. Number four is melting point. The same thing is applied here. Now, solids that are pure have sharp and definite melting point. They have sharp and definite what? Melting point, and they melt around narrow what? Temperature. That melting point is what? Very narrow. It's about 1 to 2 degree what? Celsius. All right, this is the temperature at which the what? They melt. Take note of that, which means that impurities will decrease the melting point of what? Solid. The impurities would what? Would decrease or depress the melting point of what? Is solid, which means that impurities cause elevation or increase to the boiling point of liquid, while impurities cause a depression or a decrease in the melting point of what? Solid. Please take note of that. Okay, now let me quickly say this. There are some mixtures that neither decrease nor increase despite the presence of what? Impurities. They do not increase, neither do they what? Decrease. They are constant. Such mixtures which do not increase, neither decrease, even in the presence of impurities, are called what? Isotropic mixture. They are called isotropic mixture or constant boiling mixture. Alright? They do not increase, neither do they decrease, even in the presence of what? An impurity. Such mixture is called what? Isotropic mixture or constant boiling what? Mixture. Now this mixture, they boil at a temperature that is about 78.1 degree Celsius. This is the temperature at which they boil constantly. Now, a good example is the one found in ethanol, 95% ethanol, 95.5% ethanol, and 4.4% water. All right, 95 point, is it 5 now? Okay, 6. That is 95.6% ethanol and 4.4% water, which means that ethanol and water are what? Isotropic mixture. They are what? Constant boiling mixture. Please, isotropic mixtures or constant boiling mixtures are separated through what? Distillation. I did not tell you fractional distillation, no. I said what? Distillation. They are separated through what? Distillation. Please take note of that. It is very important. Now the next one is refractometer. Refractometer. All right. Refractometer is an instrument that is used to test for the refractive index of a substance or of isotropic mixture. Refractometer is an instrument that tests or that is used to test for the refractive index of a substance or of an isotropic what? Mixture. It does this through what? Refractometry. Refractometry is a process whereby the refractometer is used to test for the what? Refractive index of a particular what? Compound. Please, the refractive index depends on the purity. Depends on the purity of what? The liquid. Don't forget this. Alright? The refractive index of a liquid molecule depends on the purity of the liquid. That is, depends on how pure the liquid is. So please take note that at this point we've come to the end of what? Chapter 1. This is the last part of what? Chapter 1. In my next video, I'm going to be discussing, or I'm going to be teaching us chapter 2, which is all about elemental analysis of what? Organic what? Compounds. How are compounds identified? Or how are they demonstrated? For example, now, for we to actually indicate or identify carbon and hydrogen in a particular organic compound, we have to what? Heat copper oxide in the presence of what? Such compound to produce what? Carbon oxide, water, and what? Copper. So please, this is just at this point to call it a day. In my next video, I'm going to be taking chapter 2 of what? Chem 113. Thanks for watching and endeavor to subscribe.